In this video lesson, we're going to discuss the difference of squares pattern. Keep in mind what we've discussed in class, that with the difference of squares pattern, the factors are going to be the exact same binomials except that one factor will involve adding and the other one will involve subtracting. So for example, x plus 3 multiplied with x subtracting 3. The expanded form for the difference of squares pattern always involves exactly two terms, one perfect square being subtracted from the other. This makes expanding the perfect squares pattern very easy. R multiplied by r is r squared, 4 multiplied by 4 is 16, and we know that we will be subtracting. That's all we have to show. In this case, 7 multiplied by 7 is 49. Negative 3t multiplied by positive 3t will be negative 9t squared. This is a good time to stop and think about what the true expansion looks like. The difference of squares pattern allows us to make use of a shortcut. In the expansion, we have positive 21t's subtracting 21t's. This will add up to 0. In other words, we don't see it as part of our simplified answer. But keep in mind that this only is true for the difference of squares pattern. If we have an expansion of 3 separate pieces, it would be helpful to use our difference of squares pattern first, and then multiply by 5. Here's using the difference of squares pattern. And now 5 multiplied by x squared, and 5 multiplied by negative 4 for our expanded final answer. The difference of squares pattern can also be used for factoring. Keep in mind that when we factor, we should always check for a common monomial factor first. In this case, I see two terms that involve subtracting. This just screams difference of squares. U squared will come from u multiplied by u, 1 comes from 1 multiplied by 1, one factor involves adding, one involves subtracting, and we're finished. This example involves 7x squared. That's not a perfect square, but it is a factor of 28. So in this case, we're going to pull out a monomial factor first, a very simple factor of 7. What's left over is a difference of squares, and we can factor that piece. And we notice that the 7 that we factored out is still part of our factored form in our final answer. In this example, 81 and 49 don't have any common factors, but they are both perfect squares, so this is a great time to go straight into difference of squares. 81a squared would come from 9a multiplied by 9a, and 49 would come from 7 multiplied by 7. Keeping in mind, one factor involves adding, and one involves subtracting. Here again we see two terms that are joined by subtraction. 256k squared would come from 16k multiplied by 16k, and 25m squared would come from 5m multiplied by 5m. One factor will involve adding, one will involve subtracting, and we're finished.